So Laduino, at its heart, it's a visual programming tool.
Visual. How so?
Yeah, visual. So imagine being able to arrange or control logic, not by typing lines and lines of text code, but by visually dragging and dropping elements. You arrange these into what are known as ladder diagrams.
Ladder diagrams.
Yeah.
Like the ones used in industry.
Exactly. They're actually pretty common in industrial PLC systems, programmable logic controllers, the kind used to control machinery in factories, that sort of thing.
Okay.
But here's the really clever part. Laduino then automatically converts this visual logic specifically into C language code, and it's tailored precisely for the popular Arduino board.
Wow. Okay. So blending that industrial logic, the ladder diagrams, with something accessible like the Arduino, that sounds really innovative. What was the main problem then? What was Laduino specifically designed to solve?
It's actually quite specific. The primary goal was simply to make Arduino programming easier, significantly easier, especially for people just starting out, you know. What's really fascinating, I think, is its unique role as a kind of translator.
A translator.
Yeah. It effectively bridges these two pretty distinct worlds. You've got the established industrial logic of ladder diagrams on one side, and then the educational, very widely adopted Arduino platform on the other. So it's designed to be a bridge, really, not just for the tech itself, but also for the learners, the educators using it.
That bridging idea, connecting industrial and educational platforms, that's really interesting. So how does that actually reshape, say, a student's learning path? What does that look like in practice?
Well, it fundamentally shifts where the initial effort goes, the cognitive load, right?
Okay.
Instead of immediately getting sort of bogged down by the often frustrating C syntax, you know, the missing semicolon that breaks everything, or the bracket in the wrong place.
We've all been there.
Exactly. Students can first really focus their energy on developing their problem-solving skills and on actually understanding the underlying control logic, what they want the program to do. That automatic translation feature, it basically abstracts away all those syntactical details, which significantly lowers that initial barrier to entry. It's really about thinking like a programmer first, without getting totally lost in the grammar of the code right away.
That makes a lot of sense. So beyond just simplifying the syntax hurdle, what about its broader impact? How does it fit into, say, modern teaching approaches or fostering creativity? Does it integrate well?
Oh, absolutely. If you think about the bigger picture in education, Laduino aligns really well with modern teaching methods, like project-based learning, PBL.
Right, learning through doing projects, yeah.
Exactly. Where students learn by tackling real-world, or at least realistic, projects, Laduino almost turbocharges that. Because abstracting the syntax means students can see the cause and effect of their logic much faster. They can test things out in simulation, iterate quickly. It's a much more fluid learning by doing than debugging lines of text. And this also strongly supports what's called constructivist theory in learning, the idea that students build their own understanding through direct experience. Laduino facilitates that direct experience, making the whole learning process feel more intuitive, less, abstract and theoretical.
That sounds like a really powerful framework for learning. So let's drill down a bit to the individual student. What's the direct impact on their motivation, their overall journey when they use something like Laduino?
Well, by taking away that initial, often quite intense struggle with syntax, Laduino can really significantly boost students' motivation and, crucially, their confidence.
Confidence is key, isn't it? Especially early on.
Absolutely. When they're not spending all their mental energy troubleshooting tiny code errors, they can channel that energy into building much more essential skills, particularly critical problem solving and logical reasoning. Getting something to work quickly, seeing their logic have an effect that fosters a profound sense of, hey, I can actually do this.